Hello children, today's video is the continuation of the topics that we discussed in the last video. So today we'll just recall the things that we have done in the earlier class or in the earlier session. So you know power is generated in the power station at 11 kilovolt. Alright, and here is the reason why we are generating at 11 kilovolt. Why not below 11 kilovolt and above 11 kilovolt? Because you know when you are generating it below 11 kilovolt, this lead to the high amount of current, because you know the relation P is equals to VI. From here, if I make I as a subset, I'll get P by V. So lowering this voltage will increase the current, and hence there might be a leakage, okay, in current, and which may result in some fatal accidents. Similarly, if I generate the power above 11 kilovolt, that will lead to the huge amount of potential difference, and hence may have difficulties in insulating the power generating station. So that is the main reason. So I have written the reason here. All right, then it is passed to the grid substation, where it is stepped up by using a step up transformer. Now what is a transformer? Now transformer is a device which is used to increase or decrease the voltage, that is potential difference. So device which is used to alter the voltage is called transformer. So here we are using a step up transformer. So transformer are of two types. One is step up transformer, the other one is step down transformer. So step up transformer, it increases the voltage, whereas step down transformer, it decreases the voltage of an alternating current. So remember, of an alternating current, AC. All right, so it is step up at 132 kilovolt. Why? Because higher. So from this relation, the same relation that I have written here, from this relation you know that I equals to P by V. So higher the voltage, lower is the current. So at grid substation, the voltage is stepped up to 132 kilovolt for the transmission, because you know electric current has heating effect on the conductor. So the wires, okay, which carry this current, if high amount of current flows to the wire, what happens? The wire may get heated up, and it may lead to the melting of the wire and disconnection of the entire transmission. All right, then it is passed to the main substation, where it is stepped down. So we use a transformer here, step down transformer, which steps down the voltage from 132 kilovolt to 33 kilovolt. Now from here, it is distributed to heavy industries such as steel industry, chemical industry, mining, oil industry, okay, and other industries where high amount of power is needed. Then it is sent to the intermediate substation, where again by using a step down transformer, the voltage is dropped from 33 kilovolt to 11 kilovolt. From here, it is supplied to the light industries, okay, such as clothing industries, leather industries, tea industries, okay, etc. So here you see that heavy industries gets power from which station? Main substation. All right, whereas light industries gets the power supply from the intermediate substation. From intermediate substation, the power is now passed to the city substation, where again step down transformer is used to drop the voltage from 11 kilovolt to 220 volt. From here it comes to our house. So that is why you will see that most of the appliances, okay, most of the appliances that we have at our home has a power rating on it, which mentions 220 volts. So you'll find that most of the appliances in India, okay, is rated at 220 volt, means that appliance works or functions best at a potential difference or a voltage of 220 volt. All right, now let's go to the next page. In the next page, you see how the power from the city substation is coming to us. So power from the city substation to us may come in following three ways. They are through overhead wires, okay, or overhead cables or underground cable. Now this cable usually has three wires: live wire, neutral wire, and the earth wire. All right, live wire is abbreviated, or the abbreviation used to denote live wire is capital L. Okay, for the neutral wire is capital N, and for the earth wire is capital letter E. So now what is the live wire? Live wire is the wire which actually carries the current from the source. All right, it carries the current from the source, okay, to the appliance or to the consumer. Okay, now neutral wire carries no current, but it takes back the current to the source. So live wire le current ल्याउँछ source बाट, whereas neutral wire ले चाहिँ current फर्काउँछ. Okay, and the earth wire. Now the neutral wire and the earth wire are connected to the, okay, together, okay, it is connected together. Where? At the local substation. All right, so as to have same potential, that is 0 volt. Now the live wire is also called as the phase wire. This wire carries the current from the source to the distribution box. The neutral wire takes back the current to the source, as I said you earlier. Now when this current is coming to our house, how does, or what path it follows? See, how does the power enter our house? So here is the topic, isn't it? So first, from the pole, in the pole you will see a fuse which is called as a pole fuse. Okay, what do we call it? To it we call it pole fuse. Okay, this fuse is not authorized by the company. Okay, only the company person or the company man can like alter or repair or fix this pole fuse. From the pole fuse, it goes to the kWh meter. kWh is the unit to measure electrical, okay, electrical energy. It is a commercial unit of electrical energy. So through the meter, see the three wires, okay, three wires. From among the three wires, live wire, okay, here live wire is attached to this terminal, whereas neutral wire is attached to this terminal. Understand, from the pole, it's coming from the pole. Now where does the earth wire go? Earth wire is connected on the body of this meter, and from the body to the body of this main switch. Now from the meter it goes to the main switch. So main switch may be of this or this one, which is called as ELBC. Okay, earth leakage, okay, ELCB, okay, sorry, it is earth leakage circuit breaker. Okay, now we can simply say the main switch. From the main switch it goes to the fuse. Okay, what do we have here? We have a fuse here. Okay, or fuse, or nowadays we use MCB, miniature circuit breaker. In place of old traditional fuse, nowadays we use this one, MCB, that is miniature circuit breaker, and through this it enters to our house, to different rooms, which we are going to now see in the next page. Now after fuse, okay, how is the wiring done in our home? Now wiring can be done in two ways. One is called as the tree system, okay, tree system. The other one is the ring system. Now among them, this ring system is the best one, or economically it is more sustainable. That's why we always do, okay, the wiring in a ring system. So house wiring is most commonly done in ring system. So here I have a ring. I have made a ring here with three wires. So I will show you now. Now you saw in the earlier page that from the fuse, okay, from the fuse it goes to the distribution box. So now let me draw the wires. So let me say that the first wire I'm attaching here is my live wire. Then see, now it has to cross the live wire, so I'll make a loop here. So this loop indicates that it's not connected to this first live wire. Now say this is my neutral wire, and the third wire I'm making a loop, two loops here, so that it is connected only to the third wire, that is the earth wire. Understand? So now what is happening? The live wire is going around and it is coming back to the distribution box. So if you see properly, all the three wires are starting from the distribution box, going to the entire building, and then again coming back to the distribution box and makes a loop here, a closed loop. Understand? So that's why we call it as a ring. So we see it as a ring, that's why we call it as a ring system of wiring. All right. So now if I draw a line here, I'll draw a line here like this. So I'll get 4 rooms here. Suppose there are 4 rooms. First room, second room, third room, and fourth room. So you see that these 3 wires are entering the first room, going to the second room, then to the third room, and then the fourth room, and again back to the distribution box. So it's making a ring. So that's why this system of wiring is called ring system. Now what happens is that in the main fuse, we place a fuse which has a reading of 30 ampere. Means this fuse can bear 30 ampere of current. Understand? Now from this it goes to the distribution box. From the distribution box, the 3 wires, it goes to the entire rooms, to all the rooms of the building. Understand? Now the appliances that you have in your room, maybe sockets, or bulbs, fans, TV point or iron point, they are attached to this 3 wires through a individual fuse. So here we'll have individual fuse for individual room. Understand? So this kind of wiring is called ring system of wiring. Now let me take the example of room 3. So in the room 3, I'll take the first wire here. This is my live wire. So on the live wire, I'll connect the fuse. So this is how we draw the symbol of fuse. So I'm talking about room number 3. Then through the fuse, it will go to the switch. So here I have the switch. Understand? From the switch, I have connected it to a, suppose say this is my fan. Understand? Through a fan. Then I need the neutral wire. So here I have the neutral wire. Now I connect this to the fan. So now when I switch it on, the fan will start to rotate. Now similarly, if I need a bulb, then the live wire, I'll connect the live wire through a switch. Then here, I have the bulb. Then the neutral wire is here on the bulb. Understand? So here you can see that if this fuse blows off, only the fan will stop functioning, whereas in this room my bulb will be glowing, and in the other rooms also it will not have any effect if this fuse of this fan goes off. So that's why it is one of the advantages in doing the wiring in the ring system. All right, so here I have mentioned the advantages of ring system of wiring. It has basic mainly 4 advantages. Let's see what are they. First one is it creates 2 paths. Now you see it is creating 2 paths. How? Because it is now going from here, the current, if this is my ring system and if this is my live wire, so the current can flow from either this direction. So if this is my room, this is third room, I need current here, so the current may go from here and reach here, room number 3, or the current may also go from here and reach room number 3. So it is creating how many paths? 2 paths. Duita bato. Understand? And hence offer less what? Less load to the wire. Therefore, you can use a low current carrying capacity wire. Understand? So economically, patla तार लगायो भने सस्तो पर्यो. So economically it is advantage. Economical advantage of ring system of wiring. number 2 it says each appliance has its own fuse. As I showed you just now, the fan here had its own fuse. Is there. Okay, understand? So fault in one appliance may not affect, okay, other appliances. Understand? Now the advantage number 3 is when a new appliance is installed, okay, in the room, no new lineup. So from the same circuit you can get another connection. All right, so no new lineup is required from the distribution box. So you do not have to bring from the distribution a new wire from the distribution to this room. From the existing wire only or the supply only you can connect the new appliance. Okay, number 4th advantage is all components such as plug switches can be used, okay, of same size, but we have to remember that fuse for each appliance must have its own fuse rating. All right, so this is how the ring system is done. Now what are the questions, probable questions that may be asked in the ICSE? Okay, in the ICSE you will be asked which system of wiring is most commonly used, or which system of wiring is economically good. So the answer will be ring system. You do not have to explain all these things. Understand? Now the other question is, in what kind of wiring system current can flow, or you can say the flow of current takes place from two paths? So your answer will be ring system. All right, now in what kind of wiring system, okay, what kind of wiring system each appliance has its own fuse? So your answer will be, see, own fuse, will be ring system of wiring. Understand? Clear? So other question may be which system of wiring is economically good? So your answer will be ring system. All right, clear? So that is one question, those are the probable question which may be asked from this particular section. Clear? Now the other one is connections of appliances, okay, and connection of switches and fuse. How are they connected in the circuit or with the mains? So all appliances भनेबित्तिकै your fridge, your bulb, okay, fan, or any other appliances which are using at your home, they are all connected in parallel. See, remember, they are all connected in parallel to with the mains, but the switches and fuse, they are always connected in series, where on the live wire. So this you have to remember. Understand? Parallel appliances are connected parallel with the mains, but switches and fuses are connected in series, where in the live wire. All right, is this understood? So if you have any confusion, you can comment or you can WhatsApp me your queries. All right, now today's assignment is write the advantages of, okay, connecting appliances in parallel. Number 1. Number 2, write the disadvantages of connecting the appliances in series. So when you connect the appliances in parallel, what are the advantages? That is question number 1. Question number 2, when you connect the same appliances in series in the circuit, what will be the disadvantages? Alright, so this is your assignment for today. Alright, so we'll continue this session in the next video.